Well, it's pretty much leveled off. As part of their presentation, David and John have their bio as part of a slide. So I'll let them kind of just highlight part of their stuff. But again, kind of like I put in the email, Dave and John were here a couple of weeks ago talking about the 811 and SUI. And so this is I think another great follow-up to that and how we can kind of build one nice, big, beautiful deliverable, right? And so, which I think I like that Kevin Hills is on here because that's part of kind of what Orange County does, right, Kevin? You guys deliver a pretty cohesive project, I think, with a lot of data in it. So
we try.
Yeah.
We're trying to do as much as we can. So we're trying to get away from PDFs and go to more GIS and digital deliveries. So I know that's our goal.
I'd still love to see something on that, Kevin. When you almost 2 years ago now, when you first just delivered that, showed us some of the stuff that you guys were delivering and how you delivered your internal projects is beautiful. So maybe someday we'll get somebody to do some kind of Esri type project deliverable type stuff. So that's cool. But
yeah, when you get a free time, a slot that comes up, we can definitely do something because we're taking over John Wayne Airport and kind of doing a whole digital twin with BIM, GIS, and then our AssetWorks management system. So kind of tie it all together.
Okay. Yeah. Maybe later this year we can give you some time to put something together.
Cool. Yeah.
Okay. All right. Well, I appreciate both John and David, you guys jumping on and presenting tonight. So I'll turn it over to both of you boys.
Well, thank you for having us.
Yeah, of course.
So good afternoon, everybody, or good evening, depending on where you are, I suppose. We're glad to be here today. Thanks to Trent for bringing us to have a discussion here, about the benefits of LiDAR and GPR in the built environment. I'd say, we've been involved in different situations when it comes to LiDAR and GPR, and then, independently, there's some good uses, but combined, there's also some great uses. So we're going to be covering that overall today in our presentation. Here's a couple of photos just to get you warmed up here. Some of you may be familiar with some of these tools or scenes that you see going on here. Of course, on the top left, we got a nice LiDAR model. In the middle, we have our Stream EM GPR, which can be pulled by a vehicle. And then we have our Stream C there on the top right, which is a nice tool that can get around and cover a lot of area. On the bottom right, we got a floor flatness scan that we did in a building. And then there in the middle, some more GPR, and then another GPR sensor on the bottom left. So some of the tools that we use on a daily basis here. So just a brief on CSTI. We've been around since 2007 and started out with a background in construction. John has how many years of construction?
Since 1996. So I would have to use the hard math to figure that one out.
So, but what we discovered it, and I've been with John since 2012, 2013, I should say. But with a background in construction and doing a lot of that type of work, it sort of helped prepare us for what was going to come next in our company and what we do, which was going to be LiDAR scanning and GPR. When you have a little bit of experience about how things get installed, it kind of helps you to reverse engineer everything and think about how you could provide this information and this data in a manner that it's going to be beneficial to the end user. We can collect all kinds of data sets, but how we use them and how we put them together is really where the magic happens, similar to like a GIS platform. You can pump in tons of data, but how do you use these data sets collectively and next to each other to create some really cool analyzation tools?
It's all about that interpretation. It's all about that data redundancy, and it's all about having the best data and image resolution you can have on the planet.
So, a little bit about us, just, briefly. I'll let John cover his.
Thank you, David. As David stated, I've been in the construction staking surveying industry since 1996. Went to the University of New Mexico, studied civil engineering and construction management. All this time that I was doing construction staking and very tired of all these people having to running over our stakes and having to do tons of restakes. All these targets we would set up for everybody. We recognized that there was a need for better quality data. So one of the two things that we realized that it's through a lot has to do with education and awareness, being able to teach and guide some of the professionals and even some of the people in the construction industry to be able to take better care of information and not hit our targets so often, because that is a representation of a lot of blood, sweat, and tears that went in from all the way from concept all the way to design to be able to get to the point where we're at right now. So and culturally speaking, surveyors have been always that, they think we don't take pride in when we work and when they do all these things to hit our stakes and not understand what it took to get to that. It's just educating about what it took to get that journey to get to that point, to put that cutter fill stake in that position. And hopefully you didn't have kids coming around and taking them for swords or mix them up in a pattern, or them not following cut sheets. So we kind of put together a campaign of being able to leverage technology to create the repeatability of the workflow processes, so that it's a tool in a long line of processes, so that we could able to go in there and be able to create the redundancy and everything that we need to create that in the work.
Yeah, and just adding on to that is, I guess, so what I also look at here is we have what we call surveying, right? We have traditional surveying, you could say. When we look at things like we're going to discuss today, it's allowing for us to use these tools to expand on what we can do as surveyors. We're not just, we're not two-dimensional, or there's a various things that we can do when we have a broader scope on, when we can look at laser scanning as a tool for various uses, different types of reports that can be created combined with other data sets. We're in 2022, so it's important that we look at information like this and look at it as something that we can implement and do all the time, and start just doing as a service. Because we've gotten flack here and there about GPR or subsurface utility engineering, that it's not surveying. And like we discussed in our last presentation, the ASCE document has the word surveyor 25 times in the instructions for SUE. So we know we play a major role, and we're excited that we can kind of break down those barriers, if you will, in creating new opportunities for us, and also to be able to educate and teach that to others, so that we can start a new thought, a new feeling about what we can offer as surveyors, because there's a lot, and we're still building on that, right? Once we introduce technology, it's limitless at that point.
And also we're here to also teach awareness in the fact that surveying does not only apply to from the ground and above. We have to look at it that it also applies from the ground below. And how we leverage this technology by utilizing some of the geophysics and the quality of that information to wrap up into our survey, it just goes down to, it's the same principles and the same practices that are applied above ground to below ground. It's just being able to create a data set, a redundancy in records, and how you put that information together to make a good interpretation of where that object sits or how it sits, and following the information and following the footsteps, and also understanding the level of quality of data that you're basically signing for or putting down the line. So I think that when we talk about geophysics, it's geophysics as applied to surveying and mapping. and understanding that we're just taking that principle and we're applying it below the ground.
Yes. So that was our presentation about each other. So
So one of the things we're going to demonstrate in our world, how we've seen in the construction industry, and this is a long line of processes that we've gone through and trying to develop this technology and how it's applied, and all the softwares that are kind of associated with that and how they talk with each other, and just trying to develop a well-rounded workflow, kind of like the BIM processes of going through the steps from creating the original digital twin from a scan to BIM method, then being able to, it's also a way of being able to reverse engineer the building by making these assumptions. But we're utilizing GPR to also look what's underneath of what we can't see with our visual eyes, and being able to model that feature and that assumption into the model. But most importantly is just understanding what that process is by introducing another detail of the sub part of what GPR can give us, whether it's a rebar, whether it's because it's a non-invasive and non-destructive test format to be able for us to go in there and be able to look at thicknesses, rebar spacing, anything in the floors, so that it helps the BIM team to be able to extract those elements and those little bits of information while we're putting together in the model, and be able to create families and a bunch of other things to be able to put that in the model. So it's learning how to apply all that methodology. We're taking everything above with the benefits of LiDAR, and then we're taking GPR, whether it's in existing construction, like a tenant improvement, historical preservation, and also applying the elements of GPR in regards to mapping some of the unknowns in regards to helping out the structural components, which it's mostly it affects by not having to go in there and have to core something or have to do any of these other things. But at the end of the day, we have to recognize that GPR is a level B application. So there has to be some information truthing or depth truthing, or just to make sure that that is aligning, because we're dealing with the laws of physics, and they have limitations because of the condition that we put ourselves in. There could be a bunch of things that affect that. So by us utilizing this process, it's showing how we take all of those elements together to create what they call in the industry as a digital twin. And using all these techniques combined, even though they're great as standalone and they have their applications, is being able to combine them and create this information-rich, comprehensive model of information.
right, and then depending on who's doing the analysis or the assessment or the interpretation, that would be like I was making that analogy to GIS. Well, what information is it do you want to see, and what it's going to be a digital twin with what's going to be the twin, what data sets combined are going to give you the information that you need to make an analysis. So a lot of in this world, of course, a lot of the orders we get are coming from structural engineers, right? That either they're needing to reverse engineer something, or it's an as-built of some sort, or a floor flatness combined with something structural. So that's typically who we're getting these orders from, and who's really using this information.
Yeah, and there's a lot of forensics that are involved in that analysis too, because the floor and all these components, obviously they function in the world a specific way. So there are all telltale signs that lead up to decisions that are made from another professional down the line. So all we're doing is presenting the report and the narrative of what we found, and they kind of take that in their analysis to make that assessment.
Which one was it? This one?
Okay, so what is GPR? I'm sure everyone has heard about GPR, and GPR is simply just ground penetrating radar, where we're injecting electromagnetic waves at a specific frequency in the ground. And as it creates a return, and the speed of the return, it creates this beautiful bunch of fuzzy looking lines that it takes you about 100 years to understand what they mean. And it's not, there's a lot that goes into GPR as far as conditions and physics and everything that's far and few between. We could have an entire topic about GPR and what it does. But what I can say about it is it's a specific tool in a process that allows us to be able to analyze specific things and features that are in the ground, identify what anomalies are supposed to be there and what are not. And it's kind of us taking the two, trying to marry the information and then making the assumption of what that object is in the ground. It gives us, like I said, a repeatable sense of redundancy in terms of the information, such as looking at the rebar spacing, and then we check the plans and say, okay, yeah, this makes sense that they spaced it evenly this amount. And it's used for analysis. It provides a bunch of different applications for a bunch of different things, but specifically we're talking about structural. Some of the other things that's beautiful about GPR is it helps us look at certain conditions of the concrete. It allows us to be able to see the health of the concrete, whether it's old, whether there's any type of degradation, if there's any type of delamination or exfoliation that happens when the rebar gets water intrusion and it starts to rust and it has a chemical reaction. And of course, that chemical reaction has a specific signature. When a radio wave hits it and it bounces back, it has a specific resistance in terms of how much energy it takes to get that back. So we're able to capture that in the radar and be able to create a tomography and be able to sit there and know just where, you know, these areas are pretty, whether they're good or bad. And we can also find voids. We can also identify the rebar spacing, and we can always, it's kind of like a tool that also could look at the health of a concrete structure. It allows us to go in there and provide information on the assessment, whether or not things are moving. You know, there's a bunch of different applications that we can go on and on, but it's really for analysis and assessment. And I think that that's how you apply it in this particular situation. And it could be the same way it could be applied with utilities.
And although there are other tools to be used along with this, besides GPR, I'd say GPR is one of the main ones though that we use. But of course, it's not, like John mentioned, sometimes it's not perfect and sometimes it doesn't always work, you know. But I think in a structural world, you can usually count on getting pretty good results, you know, with looking at rebar. If anything, maybe that the rebar mat on top could cause a little bit of difficulty getting under it, but it's a good tool.
And some of the applications in terms of how we apply GPR and the studies that we utilize is concrete inspections. And of course, that means anything like the old DOT methods of how they would drag chains over a bridge deck to, if it makes a hollow sound or if it has a specific sound, or they're tapping to see if it's hollow, it has a specific pinging sound, or like a CMU wall in a jail. You want to know which ones are filled, which ones are solid, and you can kind of tell. I mean, they're using radio waves. They're using waves from the hammer, excuse me, to be able to understand that pinging is going to have a specific sound. And the old method that the DOT used to utilize, or they probably still do, is they would drag a chain, and when they have a hollow sounding signature that comes back, obviously that's a problem area in the deck. But nothing like GPR is going to give you more of a comprehensive picture, even though it takes a lot of dense passes to be able to come up with that type of analyzation. It's a wonderful tool to be able to give you a great view of what's going on, and we'll show that slide here in a second. Again, we talked about degradation, delamination, of course, any slabs under voids. A lot of times we've been in situations where they had underwater leaks for long periods of time, and as water goes in the last with hydraulic pressure, it goes in the path of least resistance, and then your assumption that it's going over there, it could be originating from somewhere else. So that kind of helps us narrow it down. And again, the saturation of the soil is also a dead giveaway of kind of concentrating on where that leak is at, and through acoustics and other methods, you can kind of track that down. Verification of embeds, any structural component to make sure that the installation was completely done properly per the specification, and maybe they poured too quickly before the inspector got there. So we can go in there and be able to verify those types of components. Any types of assessments that you can basically think about, and a lot of forensics goes into that assessment and inspections. And of course, any types of rebar, post-tension cables, and placement verification is huge, because a lot of times when they're coring too, We want to make sure that they're not coring through a PT cable that has a 10,000 PSI strand that's pulled right, and then that thing's just going to kick out and it's going to cut someone in half. So really important to have this tool if you're in the construction industry. So here's an example of a rebar corrosion and delamination map. In the upper left, kind of the black and white, gives us the rebar signatures. And the halos or the hyperbola is the spacing of the rebar signatures. And you can see above it that the line and on the scale, you can kind of see the top of the deck would be the zero, the top of it. And as you go along, you can see that the rebar signature is coming up, and it allows you to look at the spacing and some of the other components. And then on the lower right, the right side is a moisture map. So it shows us where the intrusion of water has gone in. So there's these specific filters that have what they call this dielectrics that are dialed in to look for the index of water. And it produces a tomography, and it gives us the signatures of the return that have this type of dielectric of water. And it gives us this map. So it tells us that the water has intruded in these areas, and there's this much moisture that is retained in the slab, which is, we already know, is very bad for a bridge deck, which is the #1 cause of bridge failure, along with road failure. The one on the bottom left is just a straight tomography, but you can see that you see the lines of the rebar. And when you see those bigger signatures of in between of higher red areas, that just tells you where it's starting to corrode and the water is intruding. It's starting to get to the point where it's starting to go from rebar to rebar. So it starts to create separation because of the chemical reaction with rust. It has that exfoliation. So it's starting to, that's when the slab starts to split where the rebar mat starts to go. So here's another example of a corrosion, moisture, and cover. And what we mean by cover is, what is the nominal width of the road surface in relation to how we scanned it. And the first one we showed you was a corrosion map that gives us the signatures of how much is that signature, how much is that rebar actually corroding, and is it spreading? It kind of looks like a virus at that point, and you're able to assess at what depth and the length of it. The next one is the moisture map, which is direct polar opposite of that. All you're doing is you're changing the filtering to allow you to see how much moisture is in that. Again, that's just a filter. It's specifically tied to a dielectric of what water is, and it tells you how much is in there. And then the third one is a concrete cover, which is like a floor flatness, and allows you to tell you where all the low spots. So anything where it's purple, obviously those are the low spots when they were paving, and those are the failure points. And also, those also give you indications of where it's starting to fail too, right? And if it could heave, it could collapse. There could be a bunch of different things, but it's a telltale sign that something's not right and it has to be investigated further. So here's another one that we did. I think this is the old NMSU bridge before they knocked it down out there in exit 1. And we happened to do this study right after a survey, after it rained the night before. And the interesting thing is that, you know, people always say, well, is rain the enemy? And rain is the enemy in GPR only when it gets oversaturated. But in this case, we had a lot of rain, and it managed to give us better resolution because of the rain. Even though it was probably the perfect timing. But you can see where the points of the arrows are. Those are cracks in the deck. And I believe this deck was probably around 14 inches. And you can see just in one night and one rainfall period that it was intruding into the deck pretty hardcore. So as we were rolling over that, you can see some of the passes and some of the higher reflecting areas is where the most saturation occurs. So it was very problematic that they had to eventually replace this deck because it was already to the point that it can only last so long before they had to make a decision to remediate that bridge. So some of the uses of GPR, as you can see on the right-hand side, someone could have lost their life because they were coring through a 440 watt conduit, and they got lucky that their saw stopped before they went right through it. And that's a good example of why you need to have these types of applications to understand where these things are at, because it's a safety thing, and you cannot put people's lives in danger, especially in existing buildings or places that you don't have great information on, because at the end of the day, you're just kind of just shooting in the dark. And this is a good example about how, this is just there's no such thing as luck. I mean, that thing was just, he was just gambling with his life. And thank God they recognized that after that day, they were hiring a full-time GPR technician. So kind of give you an idea why it's important in a lot of ways. One of the other great things with ground penetrating radar is that we're able to model existing conditions. So you can see on the bottom left is that we can take a roadway, and not only can we take a design survey and be able to model those from LiDAR or the applications to create a 3D model, is that we're able to also create pipe network as-built of what's underneath. Be able to take the as-built, take our LiDAR data, our GPR data, and then we create models of what that is, and be able to create analysis. Engineers smile all day long that you have these existing pipe networks set up where they can just go in there and sample and be able to look at any type of conflicts they may have with existing utilities, or be able to look at, hey, I didn't even know what that utility is there. A lot of times we have situations where the engineer's looking at us, he's like, whoa, whose are all those utilities? And I was like, well, I don't know, because people didn't install utilities all the time, including cities, without telling anybody that they're putting those utilities in there. So there's unpermitted, unknown things or unknown assets that sit in the roadway. So GPR is a great tool to help identify those, but it's also just giving them awareness to, hey, even though this is not documented by 811, the scan tells us that there's something here. And that's the same principle as if you go to the doctor and he takes an x-ray and he says, well, there's something that's not supposed to be here. Well, they take all these x-rays to make sure when they cut you open that they're not hitting a vein or something that they know that they're going to hurt you. So this is kind of the same concept, is that we're being able to apply this to the built environment.
Very nice analogy there.
Yeah.
Okay, so what is LiDAR? I know probably most are familiar with LiDAR, but just to give you a little bit of background about it, it's a great technology. I know it's been around for a while, but it's starting to be more utilized in today's world. I'd say in the last 5 years, I've really seen it be used more and actually be requested, where sometimes we use it internally to produce deliverables, but sometimes people ask for it specifically as well, and maybe they just want even a point cloud file, which is a file that combines all the data that's collected from a LiDAR data capture. There's a lot of different applications that we've been using it for so far. Of course, surveying and engineering, doing design surveys, combining data sets with mobile and aerial is a huge value. Looking at evaluation and concepts. Of course, with highways, when you can drive down the road and be collecting all this detailed information, I mean, it's a huge benefit. Of course, mines and quarries, being able to scan something and bring it back to the office, which we refer to as virtual surveying. That's pretty awesome too, when you can bring that model into the office and be able to work on it. Looking at the built environment like we're discussing today, and structural applications. So the benefits are definitely the speed and accuracy that you can obtain. Like I said, even when we put the aerial and the mobile together, I mean, we have a really rich data set. And once we can start using filters to what is it, to filter the data, thank you, the classification of the information, there's a lot of power in that as well. And if you get really clean data, then you can start utilizing some automated tools, which you might be able to use in TopoDot or TBC. And there's a lot of power in that as well. As mentioned, there's a few different types of LiDAR platforms. The common ones that we utilize are terrestrial, setting up a tripod, and we love using our SX10 right now. When it comes to mobile, we have our Trimble unit that you see there in the middle, which has been pretty awesome. And then, of course, the aerial system as well that we have is Yellow Scan. So those are the different platforms. Here's a little bit about terrestrial. Of course, I'm not working for Trimble, I promise, but the SX10's been pretty awesome, a tool to be able to set up, and especially just for an everyday surveyor type scanner, because you can set up on your control and scan away. You don't have to worry about putting up a bunch of targets, and everything comes in really nice. But of course, you have to do multiple setups. Sometimes you can't get around certain areas. If you're in an office environment like you see on the bottom right, you're probably gonna have to do a lot of setups if you're trying to get every little nook and cranny. That can get a little timely. But the data coming from the terrestrial is really, really nice, really clean, and you can pick anything you want off of that. Okay, going into mobile LiDAR, like I mentioned, it's nice when you could drive, 40, 50 miles down the road and be able to be collecting, some tremendous data. Being able to, if you forgot something or the client wanted something additional, they wanted the trees after all, you don't have to go back. It's nice to have that. Even as historical information from a city, being able to archive the information, it could be very valuable for them. From a safety aspect, of course, I know I played Frogger plenty of times in my day, but definitely not something that I would want to put our team in a situation like that. So we really like the benefits that we get from safety benefits from using mobile LiDAR. Aerial LiDAR, again, you can collect some pretty large data sets with the platforms. Well, one of the benefits of LiDAR is that it's able to penetrate the vegetation, which is very different from photogrammetry, UAV photogrammetry, where your images, your model is going to have the tops of trees and everything, and it's a little harder to classify and clear out. So we lean on the aerial LiDAR to be able to give us a nice surface even through the vegetation. And so it's been a great tool. But sometimes you can have different restrictions. Maybe you're not able to fly in a certain area, or it takes time to even get those permissions. And it's not something you can always just say, hey, I'm going to schedule that for this Thursday, because there's steps you have to follow in order to do that. And so it takes a little bit of more coordination to get to that point. And then, looking at some workflows and different softwares that we're utilizing that I've mentioned, and also deliverable different file types. So you want to talk about the?
Yeah, so I mean, it just goes basically into the most important thing is access and planning. Of course, the acquisition. It's always going to be the right tool for the right job. You have to assess it, make sure that you put down your panels, your targets everywhere they need to go. A lot of times it's a combination of one or not all of the acquisition methods that you need to utilize. And important is registration, being able to get all the data sets to meet a quality of relative accuracy in terms of, how good is that information fitting, make sure it meets the specification. Of course, the georeferencing could be placed on whatever the constrained values of the project are, and whatever the criteria is to meet that. And then the next part is going to be extraction, deliverables. And then at the end of the day, we get to give it to the GIS guys to go out there and put a bunch of more data on their website and do more analysis. So it's probably going to bog down your machine, but hey, that's what they're all about. And then again, to some of the registration and trajectory software, some of the best in the game, you guys probably have already seen. The extraction, I know there's a ton of them out there. These are the ones that we use. And it's not a function of just one. You have to use a combination of multiple ones, because each one has a specific tasks, being able to look through information. And again, When it comes to LiDAR, the quality of sensor counts 100%. The return values of the more expensive it is, the better IMUs, the better accuracies, the whole thing. So in order to get great your ability, in other words, to get good extraction tools to work properly, you got to have that resolution. You got to have that point density. It's got to be able to identify it through the algorithm. And of course, the deliverables, you can give it to them in any way, shape, or form. There isn't any version or anything that you can give it to a person, even down to a KMZ. But at the end of the day, this is the customization that we're giving to our clients, is we're giving them a turnkey solution to be able to give it to them in any format that they need to meet the project's needs.
Yeah, I know something that just came to my mind. It's a little bit scary in a way, but we did a really awesome UAV LiDAR data capture in San Juan. And then we brought that data and we overlaid it into Google Earth, and it matched really good. Like, you know, and I was like, man, this, you know, Google keeps growing more and more. And it, you know, it makes me think about how, you know, we need to be able to protect ourselves, because it's just, who knows what the future holds when it comes to that. But it was a nice check against our data set, really, because it fit very nicely on top of the topography from Google Earth.
So I'm going to jump into kind of an example of floor flatness report that we utilized, and I'll have to change screens here. Please forgive me. So this is what we put out on the market, and this is for a forensic study for they're trying to figure out what's going on with the building, and we did in El Paso, Texas, because there was some CMU problems where they seen some separation, there was some heaving in the floor slab, so they want us to go in there and kind of analyze the floor and do some GPR. See, we see some voids. You got to give a telltale sign there might be either a leak in a roof drain, or if there's a leak underground that they can't see, because it could be those little small things that kind of hurt the structure. But kind of an idea of the color map obviously is identifying the different regions, which is overlapping the scans. And all this is doing is showing us that obviously we have 5 or 6 different zones that have a variation and deviation in regards to a plane that's established with the analysis tool. And of course, we'll get to the cross sections later, but this is kind of an idea of a telltale. Okay, this is where I need to cut my sections. It gives me an idea of where it is on the floor plan, so that we can go through and create the reports, so the structural engineer has an idea of what's going on. So a plane deviation map, obviously the bluer the color, the higher it sits below, and the red colors, it's going to sit above the plane. So there's quite a bit of difference by about 3 inches, anywhere from 0 to 3 inches when you get to that point. And I'll get into the cross section. So this is more of a diagram of where we cut the sections and did the GPR, but more we're using the analysis tools and TopoDot to be able to come up with this diagram. And then these are the random points that we sample, where we try to create redundancy by extracting the actual points themselves. I know it's kind of hard to see, but you can see some elevations in there that gives us a data set where we're taking hard measurements to make sure that we're taking these cross sections, and it's actually doing by that be able to tell out of the model that we're extracting to the cross sections when we do the analysis and the FF and the FL reports. So when we get into those cross sections, you can see that those cross sections are on the floor. So on the left side, it gives you an index of 0, and the floor is heaving as much as 2.5 inches over a distance of 90 feet. As you get to the bottom, it's kind of doing the same. So that's identifying to him that it's heaving in a specific spot, so he knows it's problematic. And obviously the structure's a living and breathing thing, so it's doing some things because there are things that are not supposed to be there. So as we get more and more, we have some stuff that goes from 0 to 1 inch. Again, on the bottom, 0 to 1/2 inch. And then we have some that really get kind of wacky in there. And at the end of the day, this gave them a pretty good analysis of what was going on in the building. So it allows them to go in there and apply a fix to the certain condition, because the survey was getting him signs of what was going on in the building, and it gave it to him in a geospatial position where he can actually go over there and say, okay, here's what it is, here's what the plans, and he modeled it, and he was able to come up with the fix, and they found what the problem was. There was just it was an underground leak, so they had to apply the fix so that they can remediate the issue, and then that way it can no longer go and create an issue for the lifespan of the structure.
And then also as a baseline, a lot of times, we got to be patient. We got to start somewhere. Like just the other day, we did a laser scan of a CT scan room. And we were thinking that maybe the CT scan machine itself was too heavy for the floor. So there was, we were going to run a floor flatness report on that, and then also go back in 6 months to do a comparison on what any movement, like John mentioned, it's kind of a living, moving thing. So we're just trying to monitor that.
So the next thing we're getting into is a scan to BIM. And I know there are a lot of you that understand what that means, but essentially we are going out there and we're doing a capture of the existing condition, and we're going to model it. And the coin term or that they come up with now is we're creating a digital twin of the existing condition. And it's very important because it's up to us to be able to visualize and make these assumptions of what the structure is, what type of frames, what type of material. There's so much metadata and so many things that can go in the development of these families, and the Revit model and families are just basically the templates and everything that could be applied to that has a ton of information, and those could be specific to a client. They could have a Revit template they want you to model it to, or there's some other things that they utilize. It's just a matter of you just being able to identify what those are before you capture the survey. Now, we pride ourselves into be able to put this in a geospatially accurate condition, because a lot of times the software kind of limits us to it's putting it in its own local software. So there's not the ability for us to be able to create a condition as it was originally surveyed, which is the foundation of the design. So we can be able to overlay all those elements, and they use the same coordinate system. So it's a beautiful marriage when you can get them all on the same coordinate system that the survey initially established. And also it allows for other consultants to get on that same coordinate system and that control system. So that way they can overlay all this stuff to be able to do analysis and anything they need to do.
And for stuff that might come after down the road, at least we have one common system that we're working off of, just trying to be a little proactive as far as that goes.
Right. So some advantages of scan to BIM, of course, it removes all the human error, but it doesn't remove every part of the human error. It just depends who's operating what monkey's turning the wrench is what we say. And understand how it is important to have a surveyor have a good scan and registered model, because they're the ones who really truly understand how, the difference between having an accurate and precise model and not the one. We want to make sure everything is combined together, because we don't want to treat the building independent of the site, because that just creates like another set of chain reaction. And it's been our experience when you marry the two, has had greater success in the construction industry. The data is collected over a considerable short of time, as opposed to someone who's carrying a measuring tape and a pad and making all these assumptions. They're not giving you the closing distance when they're doing their notes, and they're making, it just closes here. It's a square. We all know that it's not built in a square. So it's giving those errors, and it's helping us make a true as-built of the true condition. The information can be shared faster in a sandbox. So you can almost get it in real time. So that way you're publishing and people are working on it continuously at the same time. So it's being able to capture that quick. So the great thing about it is we only need one site visit. It's an information rich process. So we're able to go in there and take what you need. You can always go back and not yell at your guys for getting a measurement on the tree size or the number on an LS cap, but it doesn't get that good. You can't get a resolution on a license number on a survey cap unless you're right next to it, but you get what I mean. And anybody who's familiar with the BIM process, I'll let Dave take that over.
Yeah, so BIM stands for Building Information Modeling. And basically, it's a tool that helps manage this whole process from design and planning, construction, and operations and maintenance. but it's a process that even in the initial design stages can be pretty valuable. Being able to translate a 3D plan on a 2D piece of paper is always, challenging to the contractors and those who are building it. Being able to interpret that in a 2D world is very tough and can be very difficult. So with BIM, we're actually able to look at a model of something. When things can be designed and planned, that's one thing, but then it could be built a whole different other plan. There may be change. There's going to be changes. There's going to be addendums and change orders and things that have happened. So through BIM, you're able to track all this that's happening. And what's cool is that there's something called BIM coordination. So a BIM coordinator can work with all the subcontractors and making sure that everything's being done in orderly fashion. That where there's a maintenance box that can't be covered up by a water line, let's say, or some other utility, that there's going to be a handhold space for that to be able to occur. Sometimes we see those memes where somebody's trying to open up a electric cabinet and they can't because there's a curb in the way. It's just like these engineering, faults. And so basically this helps to minimize that. And also as an as-built tool, when you can use augmented reality and you can go out to a site that's already been built to a structural site that's been built and be able to make some direct comparisons right off the bat, just like that. But you can also use laser scanning to match and compare against different models, like a structural model. And we have an example of that here coming up. But then also, this sets it up really nice for the operations and maintenance. We get instead of getting a bunch of manuals that are like this thick and telling the new maintenance guy, facilities guy, this is how you start reading these books so you can learn how to maintain these systems. It's something that's a little bit more interactive. And again, through the operation and maintenance, there are certain activities that maybe happen. Maybe there's an tenant improvement. Maybe there's a utility that was changed or moved. Well, this can all be put into this system and have it updated. And that way, every time something's being done, we have a live model going. Now, I'm sure all of us have done a survey where we've surveyed the same thing twice, maybe even 3, 4, 5 times. And they call and say, hey, can you survey this again or whatever? Sure, we'll do it. We'll keep doing that. But we want to be smarter than that. We want to educate people to have better uses with their funds and be able to do more with it, and so using BIM as a tool to accomplish that is a huge value. And somebody mentioned before working in models as opposed to PDFs. BIM is definitely the key to that, but it's not limited to just buildings or above ground. It can also be included the subsurface. So we've our guy Michael Twohig, who we always look up to, we use some of these terminologies. So subsurface information model could be something that could be considered for under. But like John mentioned, we don't want to separate the site from the building either, or the underground, because they're all one continuous model. But a lot of times it gets kind of thought of in different different ways. But that's where some clashes and some bad things could happen. So BIM's a nice way to keep that very orderly.
And I will say this, BIM is the virtual way that PDFs will be a thing of the past. There are companies and there are jurisdictions that build 100% off a coordinated BIM model. They have what they call these data vaults where they go through and they, the surveyor gets this list, they lay it all out and they measure everything, and everything is done from a model. There's not a single set of plan because the whole system is managed through like Procore, where there's any addendum or changes. But see, the BIM has already built it once virtually. So the only thing that they're trying to do is to make sure that they're installing it and complying with the model. So that way that the electric guy is not fighting with the fire suppression guy or vice versa. Who goes first, right? That's the constant battle. Is the coordination is the key and all this. But another great thing that Dave pointed out is always the life cycle of information, is that this isn't a rolled up set of plans that sit in someone's desk or somewhere. This is made available virtually on a system that the owner already pays for. So it pays for itself. So that way, and down the line, like you said, that all you have to do is just give them access to the model, and it saves costs of having to do any improvements.
And speaking of the data vault on the site, so while this coordination meeting is going on, things are being done on live, you know, and then they update the model, hit the button, update the model. Well, the subcontractors on the site have a nice computer that can be set up with a nice screen, and collectively those subs could be standing next to each other and be looking at this model and moving it around in 3D. Oh, I see how this goes under this and over above this and so on and so forth. So again, a lot easier to see that in 3D and already built than trying to understand the 2D aspect of it.
So you're saying surveyors might always not have to request CAD files, and we might always have the most updated plans.
That's right. Imagine that. Imagine that.
That's
In
a
the
good,
original
that's a
coordinate
good
system.
bold statement there. I love it.
Yeah.
How many times we need CAD files? They don't exist, right?
Right. Yeah. Or on the utility side, do you have any as-built maps or any
Right.
historical maps? No, no.
Right.
they're not in.
I
So
love
yes,
it.
this is the best way to make best use of this information. And like I mentioned earlier, it's expanding on what we do. We're not just doing a topo, we're not just doing a boundary survey, and not to discredit that by any means, but there's so much more stuff that could come into this, into the technology in the world that we're living in today, and it has a ton of value.
Yeah, that's awesome. Love it.
So a little bit of what can be modeled, you know, Revit is an Autodesk tool, or was it? Yeah, it was an Autodesk tool, or it is. But there's a lot of structural elements that can be modeled, whether it's structural columns, any types of beams, beam systems, bracing, structural framing, structural connections, detail, steel modeling, and trusses. And if you can even get down into where you can scan with your GPR, you could even get into the load bearing parts of it, any of the foundation structures, and make those assumptions and be able to plug those in, and you know, any of the grade beams and stuff like that. So this is just small bits and pieces. You can model it down to all to the light switches if you wanted to. It's just, you know, there's always what they call an LOD, which is a level of detail modeling system that they utilize, but specifically this is just to put together just the bare bones, and they kind of built the whole thing upon that. So there's an example of what a framing structural component looks like in analysis. It's pretty, and these are all built off of submittals, right? So each submittal is from a certain, like the structural engineer will have all of the beams, and have all the systems, and then you have another component of that utilizes the same truss systems. And so we kind of put all these submittals together to make sure that those systems fit correctly, so that way when they go cut them at the manufacturer, everything is just a measure twice, cut once scenario. So here's an example of how we bring in a point cloud into a Revit environment. And as you can see, from the circles are where we had our scan stations. But the Revit was based upon an outside and inside scan and some of the other elements. And you could see that there are some areas that we couldn't get because these were like bins and stack trays that were there. That was very difficult to get into. But because of the point densities, and we try to get in where we could in between, we had enough density so we can create enough assumptions to be able to create the floor plan, which is overlaid. This is overlaid, and be able to create the grid system, and to also take the existing plan set, be able to look at to see if the measurements on that building system match to what the built condition was. So that way the structural engineer can make informed decisions of whether, because this specific case, they wanted to put heating and cooling units on the top, and they wanted to make sure that the momentum frames were able to handle the load. So we had to get all these little bit of the details and be able to model this to be able to help in his decision. So here's an example of a momentum frame with Revit. We've taken the families and we've created the actual momentum frame, but you can kind of see the purlins and all the frame structures and the actual beams itself. You can all the way go down to the bolts. And he was able to even model all the other components, which were the bins, the structural bins, and be able to know where that space is. Because it's totally about utilizing the space and understanding was there. The better information you have, the less assumptions you have to make. And it's kind of like you're not just one-eyeing it and being able to go out there go back to some fill notes that could have been off plus or minus whatever. But at the end of the day, this is kind of what the finished product looks like when you know that it's coming together as it should. And this is a Revit model of the digital twin. And, you know, we did some rendering with a program called Enscape. It's a plug-in Revit. So we're able to visualize a space with a client and go in there and, you know, just turn it around, cut it 3 ways to Sunday, and be able to understand how to utilize that space. So at the end of the day, it's not only visually appealing, but it serves a lot of functions because there's a lot of information that goes into applying the information to these models.
We have
On that one, just what do you think total man hours spent field and office on what you've put together right there?
40 man hours to build the model, the digital twin, and probably a day in the field. So probably about a total of 50.
Yeah. And how much of the Revit side of it is automated, or is it?
It's pretty automated.
Yeah.
You just got to make sure that you have the right templates, and you know, the architect or the engineer gives you the right information, and it gets put together pretty quickly. So once you have that established, it's just a matter of just picking through the model and just clicking, and it kind of is really automated.
Yeah, and we have an associate. His name's John as well, John Dillinger, and you know, we wanted to see if he could join us today to add some of this because he really specializes in creating these models, and you know, so maybe for future mentoring Mondays could be
Perfect.
something. And he's totally with knowledge. What's cool is that he's straddled the architectural world and the survey world, so he knows the best of both. You know, he understands how to make it, you know, cost effective and not trying to lose a job because you're trying to do too much for somebody.
Yeah.
You know, it's like, hey, this maybe you don't need all that. Let's turn it down a little bit. Let's find the right balance of what it is.
Right.
And that's definitely powerful because this stuff could get out of hand really quick.
Yeah, for sure. For sure. George got a question. Go for it, George, while we're on here.
So you can take this, this view here and rotate it 360 degrees any manner you want to show any detail you want within the inside of this. I'm guessing this is a warehouse, but so you can show any detail you want within this plan.
Yes. And
That's
you could
pretty
create
cool.
and you could create 3-dimensional coordinates from this plan. All we would do is we would get this model and bring it into Civil 3D at a 1-to-1, and no scaling, 1-to-12 or 12, whatever it is, and be able to bring it back in and be able to generate 3D coordinates. And you can even do it in sections and all the way down to the anchor bolts too.
Good stuff.
Yeah, there was a model I saw for the Minnesota Vikings new stadium and stuff, and they were talking about like their locker room and this other room they had where they brought people in, and being able to understand how to use that space, how the lighting would look. They decided that they didn't like that particular lighting, so they were able to switch it up. And so it's cool that you could do all this initial building before you actually go to actually doing it. And especially if it's something really special like that, it has a ton of value.
So think of this applied to the survey world. You know, you could have a survey information model that has the exact same components. It's just information, but it's just represented in a different way. It's just information modeling. And what goes into that, it's kind of the way with subsurface utility engineering. It's kind of the same thing, is that you're trying to be the best representation of that virtually captured condition. So that's why they call it a digital twin, because the surveyors are the best candidates because they're the ones that are capturing it. And that's why GPR and some of these other tools and being able to take these concepts and being able to apply that, this is just on a different scale, but we'll be able to create something specifically for information modeling for surveys and subsurface utility engineering, which there are some out there. It's coming.
Like for example, here we figured that we needed to see how much of a load these could hold by doing the analysis with the GPR on the front end, and then being able to have that information applied to whoever's building these racks and these systems.
Yep.
So it's kind of how they could go together there.
Go for it, George.
So I guess this is either good news or bad news. This may be the next step in the ALTA survey process.
Yeah.
The inside survey of commercial properties and
Yeah, no, I know. Like I've had some really nice ortho maps, and I'm like, well, there's my Alta right there. Why why am I gonna draw a line over this curb line when it looks so clean here? And then, then once I did my survey, then it started to get too busy. Then there was too much
Yep.
stuff. Yeah, I'm with you. At what point? And then again, that's us having this, thanks to Trent having a platform like this where we could discuss this to introduce that type of thinking where we can say, hey, wait a minute, where maybe we need a change, or we can consider about how to do this or this. And it's a new way to present the information. But it's, yeah.
So,
A photo's 1,000 words, though. I will say that.
so now at my age, all I have to do is become computer literate.
Yeah. Well, either that, or that's the next generation of people who are used to, they grew up with an iPad in their hands, and they're my son plays a game, and when he plays it makes me want to vomit watching it, but that's just a different thing, and it's setting it up for future people to be able to come in and take this and run with it.
Well, just for perspective, I grew up with a slide rule in my hand.
That's what Jerry's showing right now.
Yeah. See, so I mean, just if we look at the progression, especially in the last 20 years, it's exponential. So.
Well, the one thing we can never lose sight of is that understanding the blood, sweat, and tears that goes into making a survey in the 80s, the 70s, the 90s, the 80s. Yes, it's easier to do it this way, but unless you have the quality of information, and that's not vetted and it's not redundant, it's just doing what you're telling it to do. You kind of lose sight of the measurements. Like when we went from total stations to GPS, it was always that concept is like, well, how can I really check it if I can't do right triangles to check that or anything like that, right? It's the same concepts that apply to here. We just got to make sure that our methodology, we're teaching the next generation that just because it looks good doesn't mean it's good. You have to go in there and you have to check with hard field. You have to take redundant data and create it with redundant information back and forth. And you always have to apply, you always have to critique it in so many different ways till Sunday.
Yeah, which is, like you showed that prime example on your floor flattening report, right? You're in there with your traditional topo shots to back check it against, the GPR. So we got George going. What's up, George?
Well, and then the last part of this equation here is you got to learn to charge for the value of the information that you're providing your clients. And we've done a terrible job of that in the past as surveyors.
Right.
We're a valuable resource, so we need to get paid for that information. We're certainly liable for it.
That's right.
Right. Yeah, like John mentioned, 50 hours to produce this. Yeah. But if I charged my normal rate times 50 hours, well, yeah, we're losing out. You're absolutely right.
Mm-hmm.
And everything nowadays, it's just they want it faster, quicker, and you're right. If we don't establish that, then we're going to be taken for a ride every single time. And it is a lot of value. I mean, the investments that we made and all the tools and the softwares and the training and the technology to be able to make it, a little easier. There's been a ton into that, a lot of investments.
Yep,
right.
Exactly. Love it.
Okay. So we got a few more things here.
Yeah.
Just a few more examples. Here's a scan to BIM comparison. Right there, you can see where a scan was done and compared next to a BIM model, and we can see things are shifted over a little bit. So it's a nice little direct comparison tool that you can use. And then I think this was the last, one of the last things, this steel report. And just give us a sec to set it up.
Yeah, but the one thing that we never lose sight of is that, we have to start thinking about how we're going to represent the information, even though, we may not actively be doing it right now. We have a voice into how that information has to be represented in the next generation. We got to set up the tools so they can follow in the footsteps of that information. So here's a report of this is a beam erection report, just letting us know what the build versus the scan. And I'll let David go through the report.
Yeah, so this was over at NMSU, and the part of the spec called for verifying once the steel was fully erected to do some verification and compare it against the steel structure model. So here's some direct comparisons that were made. This is a really nice report that was put together, but you could see the point cloud dots inside there, and then you can see how they're compared right to that model. So just by looking at it, right, that one in particular looks like it's pretty good. It's looking pretty good there. Here's another example. Some of the fuzz you see there on the top, you know, is just some LiDAR shots that were kind of shooting off into the air. But again, you can see how the direct comparison can be made. And again, like John mentioned, the georeferencing, that was the power in this. You know, Victor, the guy that made this report, he was able to just basically import this data directly into the model, and it was set up. He didn't have to do any scaling, any stretching, any moving, or anything like that.
And the thing to that is that you get a lot of people who get a scan model and they do the best fit scenario, right? They're like, oh, I'm going to fit it to the best the way that the condition is. This is not the way it was done. We were controlling, we did the design survey, we did the layout. So it was independently tied to the control system, and it was a one-to-one comparison, as opposed to you get somebody randomly to go in there and check it for analysis, and it's really not a true representation of what that measurement is, because you're only applying the condition to the best fit scenario.
So yeah, so it's a nice report. Here's an example of something that was incorrect. It says outrigger is shown clearly in the wrong place. So just by doing that direct comparison, boom, there it is. And so we can report this back to the contractor to go make any changes or any fixes.
Yeah, and they can apply the fix before the next consulting gets in there and starts to do something, right? So it's not holding up the job. That's why this is a project saving tool.
And again, there's some more references of some things that were inconsistent with the structural model. So it's just a cool comparison. I always like this one just because it's a really nice direct way to see how the two could be put together and represented. And like John said, how is this information represented? And in a report like that, it comes out looking really nice. So that concludes our presentation there. If I know we've had a few questions. If anybody has any other questions, you know, we can answer those now. And okay, there's one.
Yeah, Kevin's ready to go.
Yeah, I'm ready to. Kind of stuff, man. It's like a drug to me, man. I love this stuff. Good job, guys.
Thank you.
Couple. I like what you guys said about the putting together kind of a group, a team to kind of go over this stuff, because it's really important. You know, there's pretty much like the largest construction companies are already doing this type of thing. They're getting into virtual design and construction, right? So I'll put a link in here, just so Trent, you like the links, so I can kind of follow up with this one. But this company, this coalition is a bunch of construction companies that are largest construction companies in the country, and they've done the same thing. They've kind of put together, coalition to kind of go over these issues, and they're struggling. I mean, I listened to a couple of their seminars and webinars, and they don't have surveyors in there, and they think that they can, do all this stuff, and they don't know why they're having problems. And most of it is because they don't have surveyors that are, involved in, coordination and putting this stuff together. So, one of the things that we're doing, and I think a lot of other agencies, where I'm with Public Works, so we have in the County of Orange, we have about 800 buildings that we're just starting to model and put a facilities management model together. So what we're and us and a lot of other groups in a lot of other agencies are starting to put this information into an asset management system. We're using a application called AssetWorks. They have Maximo. There's all these other groups, and what we're helping out with is in our group is to take the GIS, the BIM data, and then take the asset management information and sensor data and basically marry that up. And then now they can start seeing where issues are. And that's going to be huge. I mean, there's going to be a huge opportunity if surveyors, we talk, especially in California, we talk about, we lost GIS. Well, in truth, we never really had GIS because I don't think we invested in it. I think we wanted to, have the law kind of change so that everything had to go to us, but we didn't really invest in the time and the effort. But now is the time for us. We really have to get ourselves motivated and get ourselves tied together, because all these other companies, all these other groups are doing it. And if we don't, we're going to be basically fighting for boundary surveys and, doing, we're going to be, we're going to be the, we're going to be the, I look at it, it's kind of like you got the owners and you got the renters. We're going to be the renters of the world, and the engineers and the architects and the contractors are going to own everything, and we're going to be, pushed aside. So we have an opportunity now to really take over at least a part of this digital twin concept of, at the beginning, they need that coordination, and at the end of the handoff side to, go to the operation side. There's nobody else that can do this stuff. They'll want to do it, but we have that knowledge and that, that background. So we really need to put our heads together and tackle this one.
Yeah, and that's all great stuff. I am right there with you. And it's great. It's nice to hear that somebody, being, you're not super far away from us being here in California, but just to hear that echo of the same thing and the same pain that we've been feeling, and like just wanting to expand on that. We're always wanting to push the limits of what we can do. We've never been satisfied with just being, the status quo, or, just doing the minimal. So it's that type of thinking and where we need to take our industry moving forward, and capturing all that. And otherwise, like you say, it's the last of a dying breed unless we all collectively decide to make some changes and introduce some new things. And then that we've discussed also about this technology taking away jobs. It's a 1-person crew now instead of a 3, 5, 7-person crew. But if I look at my office right now, I have it full, and there's a lot of people doing point cloud extraction. Well, you can use an IT person, a programmer. There's all these different job descriptions that are going to be present in a 2022 surveyor's office. It's not your typical, back like when I started, or anybody else. It's a whole new world, and we need to learn to embrace that and not be scared of it.
I think the other, to your point too, the one thing that we don't realize that's what's ahead of us as far as what's going to take over information modeling is going to be some form of AI too.
Yeah.
At some point, if we don't control how that AI is managed and how that's processed, or there's no oversight, so to speak, on that information, or how it's represented, it could very happen well in our lifetime where we'll get to a point. And I always bring up the show, a good representation of how that is mismanaged. And there's a little bit of surveying and some engineering, is the show Westworld on HBO. They're modeling behavior of people. They're modeling how they build buildings. They're modeling, where to put it. Robots are doing the majority of the work. It's just like this whole symbiotic relationship with information that's basically come full circle, and how they apply that to the human race. But I think it's very important that we take that initially and we take control of it, and, breaking cultural barriers from the conventional surveyor role, and go out there and be at the same table as the owners and the architects, because they have a voice on how important it is to be able to capture this. Because at the end of the day, surveyors are in the role of always being retroactive, right? We're always being in that scenario where we're always having to go by and apply fixes, where we're doing what do they call that?
First to go, last to know.
Yeah, exactly. We're doing like indirect value engineering, only because we don't know any better, and we're only trying to make sure that because they're always on our butt about, hey, you need to get the staking done. I don't want to submit an RFI. It takes too long. Just apply the fix and we take too much on our shoulders without realizing that, hey, we need to stop this and be able to see our value in our roles in this. And this is kind of like a huge step in being able to do that, is be able to model and find all those problems before we apply those methods in the built environment, and we go out there, and that way it minimizes our risks as surveyors and business owners.
Yeah, and that, like you said, is wanting to get at that seat to have that initial talk with the owner. We're one of the first people he calls, if not the first person. And we want to get to that point where and this has happened where we can call an engineer and say, hey, I got a job for you. You know, this, we're bringing value to on the front end and on the initial stages that we can help to find a solution for them as well, even before it goes to that step. So,
and to get a seat at the table, we must communicate. We must, surveyors are always sitting in the back and not wanting to talk, right?
Exactly.
Kevin brought up Kevin emailed me about a month or two ago about finding how we can incorporate leadership's classes for surveyors as well, right? And so it goes back to that same stuff, right? We got to be able to communicate with the client. We got to feel comfortable sitting at the table, right? And so those are all aspects of, thankfully, the Gen X's and Z's and that kind of stuff are a little more comfortable somewhat, pulling out from behind the computer. But those are some of the, tactics that we have to work as a profession, right? And being comfortable at the table, that's the biggest thing. And then one other thing I was going to talk about, all of these digital twins, right? You see some of the futuristic type stuff where they're wearing the Oculus glasses and they just put them on and they can see what utilities are laying in the ground underneath them, right? And that's, again, part of that futuristic type stuff that eventually will come into play as built all this. And like Kevin says, start doing all the asset management of their facilities. Somebody's just going to put on glasses and go, oh shit, there's a 400 kV power line in the bridge deck. So I think all of that eventually will come,
and that won't line up the way you want it to unless there's a surveyor involved to make sure it's tight, or else they're going to point it at that manhole and the manhole's over there.
Yeah.
This thing doesn't work. Let's move on.
Right. Right.
So it starts
instant gratification.
It's a huge, again, the surveyor has to play a role in initially setting that up.
Yeah, exactly. Go for it, George.
Well, I'm going to say we need to step up and be proud of what we do and take credit for what we do and charge for what we do. And by the way, my wife says I talk too much.
Same
thing. That's funny.
Yeah. Once we unmute George, he's good to go.
So just a few last things.
Yeah, go for it. Talk about your.
Yeah, I was gonna say there was a question here. Oops, I was trying to. Okay, George. Yeah, thank you, George, and for sharing that.
Yep.
So yeah, we missed out on the GIS. We don't want to miss out on anything else.
Right. Yeah, exactly.
Oops. Oh man, I think I missed
Yeah,
it.
I put a link.
That was just a plug to talking about expanding on what we do. If you're interested in that type of thing, we were featured on Beyond Oak Island show, doing some subsurface work here. And so again, it's something that we never expected to get into that type of realm, but here we are pushing it. And then while we're there, we get to say, hey, talk about surveyors and how this is all included in what we do and be able to represent our industry in a different realm. So that's what we're all about. And so that concludes it.
And Trent, I have one tip. This is going to be a future show. We're going to be filming for Discovery Channel and that on some other sites.
Sweet.
But this will be a next show, guys. Hopefully next summer. After they preview it, because we can't do it before they preview it, but it'll be on applying a little bit of geophysics and surveying and archaeology.
Nice.
Going out and looking for, and if you guys are from Arizona, we're going to be in the Superstitious filming for the Lost Dutch Mine, Dutch Mine, I believe it's what it's called.
Okay. Sweet. I can't wait. That'll be cool. Have you guys started the project? I'm sure there's
already a bunch of research in there. We're going to do the oversight on the GPR and some of the other geophysics parts of it with magnetometry and some other stuff. So we're going to take the redundant data and we're going to apply some redundancy to it to see what the interpretations are going to be. So stay tuned.
That's awesome. That's awesome. Is the Oak Island thing on YouTube or anything where is that episode anywhere that somebody can watch online, or is it a subscription based?
It's a
History Channel.
It's a History Channel. We can send you guys a link, and then there's actually something even more interesting is there's a after show like after Beyond Oak Island after show on YouTube that I can send the link to you guys and Trent can have for distribution. That it kind of talks about like, wow, did you guys really find anything? Well, I would say watch the YouTube video and stay tuned.
Yeah, the
Yeah, no.
show, of course, it has to fit into a certain time frame. But there's if you follow the show that he's talking about, the YouTube channel, it's a lot more detail about the
Okay.
process and what happened, and with some other, you know, archaeology nerds that have a lot of good questions, discussion about it. So it's a really cool thing.
Okay, cool. Yeah, shoot me those links and then I'll shoot it out to everybody. And then
All right. Well, thank you guys. You guys are always a pleasure to be in front of, and
I love it.
hopefully if there's anything else you guys want to see or reach out to us, we always answer our phones.
I love it. I appreciate it. Kevin, did you have anything else? I know you.
Oh, it's cool. Really appreciate you guys doing this. I can see how much time and money you guys invested in this operation. So it's,
Yeah. Did anybody else have any questions? I know nobody else really kind of chimed in, but I want to make sure nobody else had questions before we jump off.
Mike LaFontaine is here. I can see him in the, I don't know if
Yeah.
he's muted or if he's just signed on here, but
No, he put in there. He put in the chat. Excellent.
Okay.
Thank you.
All right.
Cool presentation, guys. Thank you.
Yeah.
Thank
Thank
you.
you. Thank
Appreciate
you
it.
all. Appreciate it.
Awesome, guys.
thanks a lot, guys.
Have a good one, gentlemen.
Thank you,
Bye-bye.
guys. Have a good week, everybody.
All right, too.